Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and so in a video about 2 years ago, I talked about Cantor and his cranky ideas, and I've had some back and forth with one of my subscribers or one of those people who have visited my channel, and I'll place a link so you can see the conversation. It's between somebody called Tom Cummings 2436 and myself. So the gist is that if you look at this uh, utter crap of bijective cardinality, it rests on several anti-mathematical theories and anti-mathematical rot, because most of the stuff that Cantor did is not mathematically substantiated or proved. It's really more a system of beliefs, like a cult or a religion. So a line does not consist of points, okay? A line is a distance between 2 points. You cannot actually draw a line. You cannot draw a circle. These are not circles here, by the way. These here are representations of particular distances, okay, which are uh, at the same distance from a given center in a plane, which is a straight line, okay? A straight line distance. The same shortest distance on any of these uh, distances or paths. So you can say that, yes, that all the distances here are mapped from the smaller arc to the big arc, even though the large arc has distances that are not on the smaller arc. Okay, so a point is like a sign alongside a road or a path. Okay, it's not part of the line, just as a road sign is not part of a road. So when we talk about this straight line, this dotted blue straight line here intersecting these arcs here, well, that's just stating that we can find points of or locations of intersection between the line and the circles. Okay, that's all it's stating. It's saying nothing about the number of points. So one can't say anything about the number of points on the small arc and the large arc. They have no equinumerosity. Okay, and in fact, neither do the distances, because it's just a scaling of a smaller distance to a larger distance. That's all it is. So it would seem to appear that we have equinumerosity, but they're never the same distance. Okay, so the distances are different, and you're not mapping points because you cannot distinguish all the points in this interval or in this line. Let's say you have a set with all these points. You can't say that all the elements in there are distinguishable. Okay, so on the one hand, you can talk about the set being uncountable, and on the other hand, you can talk about points being in correspondence with each other. Doesn't that blow your mind? Isn't that a contradiction in terms? Of course, it is. You cannot talk about uncountability, then a correspondence between points, as that demented Jew Georg Cantor thought. Okay, he was an utter imbecile. So was David Hilbert and all the fools who followed him. Okay, so in this discussion, I tried to explain to Tom that there's nothing wrong with the definition of a point. It is exactly what it should be. Okay, and like I said early on, if you have a line falling in a systematical way on these two arcs and going from this direction to that direction, then basically all it's doing is saying that there are 2 points of intersection on the line with the arcs. That's all it's saying. That's about as remarkable as it gets. There's nothing more to that. So Cantor's ideas were complete rot. And so he says the mapping from y is equal to 0 to sine of x plus 1 does not mean they are of equal length, but it implies that every distance is scaled by a factor. I say that is scaled by a factor that maps it. Okay, so they're not they're not equal, and it says nothing about the points themselves. So when you look at this here, you're not really dealing at all with the points, because you can't distinguish all the points. All right. You can only find certain locations. People think, oh yeah, that the circle is a solid line. It's not a solid line at all. Okay, there is no such thing as a continuous circle. That's just utter garbage. I mean, because a circle is uh, a geometric object with a particular distance that is formed. Okay, so it's a special kind of distance, right? That's all it is. You cannot draw geometric objects. That's one of the fatal flaws in understanding of most math professors and math teachers. They do not understand geometry or what it's all about. So the distances can be scaled or mapped, and that's nothing remarkable. But a bijection in these examples is not one between points, okay? It's one between distances. And it doesn't mean anything because cartographers knew about scaling hundreds of years before that idiot Georg Cantor came along, okay, and infected mathematics with his drivel. So again, that's all I wanted to bring to your attention, and hopefully Tom can watch this, and hopefully I've answered all these questions. And as a accompaniment, I've written a little article with the help of AI because my eyes are not good, called Cantor Delirans. I won't say what delirans means; it's a Latin word, and you can look it up if you're interested. And I discuss bijective cardinality and the anti-mathematical drivel that infected mathematics. So I start the discussion with uh, telling Claude that I wanted to explain the concept. So I'm not actually trying to take it off the rails, so to speak, you know, from mainstream mathematics point of view, but rather to prompt it to give me a certain explanation. Well, doesn't matter how hard I do, each answer is refined and to a certain extent better than the other answer. But eventually, uh, Claude realizes that it cannot explain the concept, and it gives up. You know, it says that this is a deeply problematic concept, and the two arcs are representations of distances, not sets of discrete points, and it also uh, gets into a little sidetrack about continuity and discreteness, but that's not really relevant because we're dealing with distances. Okay, and I explain these things to Claude, and of course Claude fails, and the admission comes later on in the dialogue. I'm not going to show you where, but you need to go to this article and read it, and I'll place a link to it. If you're not already a subscriber, become one. Tell your friends about this, and also become a follower on Academia. Okay, I have a substantial number of articles on Academia, and I do know better than anybody else. So you'd be hearing from the very best, and that's me. Um, you can become a follower here so that you don't miss out on my articles. And that's pretty much it. Click like, and I hope to be speaking with you pretty soon. Till next time, goodbye.